So for today's notes, we're going to look at a review of long form, and we're just going to do a couple of sample problems together. So there's no notes template for this. We're just looking at a couple of sample problems. So there's our first problem. And you want to think through order of operations and kind of undo that order of operations. If we knew what x was, we would take care of the multiplication first and then the subtraction, because that's what order of operations would tell us. But when we're solving, we want to go through that backwards. So we want to undo that subtraction first, and that with this as the given line, then we want to take care of subtraction, and that involves definition of subtraction. So let's apply the definition of subtraction, which changes subtraction to adding the opposite of what's behind that subtraction sign. And remember, we just label that as def sub for definition of subtraction. And then definition of opposites will typically follow that. With taking the opposite of 4 and just writing that as -4. And that is the definition of opposites. Now again, we want to deal with kind of reverse order of operations. So the addition would come before the multiplication of 9 times x. So we want to kind of undo that addition by adding its opposite to both sides. And that's a property of equality. So we're going to take what we have on the left-hand side of the equal sign, and we're going to add 4. And on the right-hand side, we have 9x plus -4. Now that's more than one term, so we put it in a grouping before we add our 4 to both sides. And that is the addition law of equality, just saying that I can add the same thing to both sides without changing the value of the equation. And then, again, our goal is to kind of take a look at combining these two to get rid of them. So we want to regroup. So right now I'm going to keep the left-hand side the same. Over here I'm going to group the -4 and 4 together, and allowing me to change the grouping of things that I'm adding without changing the value is associative of addition. Now I can go ahead and add those, but just one property at a time. I'm going to do my addition on the left, so that's -36, and because that's substitution, which is different than adding the opposites, I have to kind of wait for that there, and I'll just call that substitution. And then in this next line I will add the -4 and 4, and -4 plus 4 gives me 0. Of course, that is the property of additive inverse. And then we know that when we add 0 to anything, it just is whatever that anything was, so that's 9x, and that is additive identity. Now our next goal would be to get rid of the 9 being multiplied by the x, and that's going to take a property of equality. So we're going to multiply both sides by the inverse of 9. But of course, again, both sides, if I'm going to multiply, I have to multiply on both sides of the equation to keep things equivalent, and that's the multiplication law of equality. Now over on the left-hand side, I can go ahead and do that multiplying to shorten things up, but that's a different property than what I will use on the right, so just one property at a time, and that would just be substitution. And then on the right-hand side, I want to get the 9th and the 9 together, so I need to regroup those and make that multiplication the first thing in order of operations. And so that is associative of multiplication. And 1/9 times 9 will give me 1x, and that is multiplicative inverse. And then, again, that multiplying 1 times anything, just being the anything, so it's just leaving us as x, that's multiplicative identity. And so we can say, okay, our solution is probably -4. Now we should check. So I'm just going to go over here to the other side of my board and rewrite my given to do my check. So this little check mark. And I would plug in my hopeful solution, which I think is -4. And then I don't have to do my check in long form, so I'm just going to go ahead and do my multiplication and subtraction. And when you get the same thing on both sides, then you know you have found the correct solution. And so we'll take our solution of -4 and note that in set braces. And that's our first long form review. We are going to do a second problem. So if you need more paper, you should get that out. And I'll pause for a moment and you can get ready for that. So our next long form review practice problem is 2/5 x plus 12 equals 6 as our given. And again, you want to be thinking about order of operations to kind of go backwards through it. When you're solving, you're kind of stripping that order of operations away. So if I knew what x was, I would do the multiplying first and the adding second. So if I'm solving, I want to go through that backwards to peel it away, which means I'm going to take care of what's being added first, that plus 12, and then take care of the multiplying. So I want to get rid of the plus 12, which means I need to add its opposite to both sides. So again, on the left, because I have more than one term, we want to show, okay, this is what I had on the left, and then I'm adding the -12 to that side, and of course I have to add it to both sides, and that is the addition law of equality. Now I do want the 12 plus -12 to be the first thing in order of operations, so I have to use the properties to make it the first thing in order of operations. So that means I'm going to change the grouping of the things I'm adding. And of course the property that says I can change the grouping of those things is the associative of addition property. And then I can go ahead and add those. And 12 plus -12 will give me 0. And of course that is additive inverse. And we know that when we add 0, it does not change the value, so we can drop that. That's additive identity. And we can do the addition on the right-hand side. 6 plus -12 would give me -6, and that is just substitution, just putting in a value you know is equivalent. And then that's going to allow me to just have the only kind of operation that's left with x is that multiplying. So I want to get rid of that multiplying. To do that, I'm going to use MLE. And I'm going to multiply by the inverse of the coefficient. And that's the multiplication law of equality. Now again, I want that. I'm trying to kind of combine those factors, so I do need to change the grouping to group them together to make that the first thing in order of operations. So I regroup those. And that's associative of multiplication. When you multiply 5/2 times 2/5, you do get 1x there, and that is multiplicative inverse. And we can either deal with the 1, or I'm going to deal with the multiplication on the right-hand side. So if I take 5/2 times -6, I get -15. And you know, you may use a calculator for that. If you, I'm just going to go through a little thought process here. I get -30 over 2, because when you're multiplying fractions, you multiply top by top and bottom by bottom, and that reduces to the negative 15. So if you need a little thought process to go with that, there it is. And then we have that one coefficient, which we know we can get rid of, and that is multiplicative identity. Oh, I need to go back up here. This is substitution, just again putting in that equivalent value. And then we should check. So we're going to go over and I'm going to rewrite my original equation to do my check. And plugging in my hopeful solution of negative 15. And then, when you're plugging the value in for x, then you do just follow order of operations. So again, kind of going through that thought process, I get negative 30 over 5, because again, that's fractions, multiply top by top and bottom by bottom. Now you could do that all at once. If you're using a calculator, know the answer. You can do that in your head, that's fine. So here I would get negative 6, a little lasso there. Negative 6 plus 12 equals 6, which of course gives me 6 equals 6. When you get the same value on both sides, you know you've found the correct solution. So then we'll take that and put that in set braces. And that is our review of long form. Make sure you're bringing your questions in to your math teacher.